Are we live? Seems like we are. Welcome. Oh, I don't want to open this yet. Welcome to another Tech Day Live. I'm the Duke. The purpose of my streams is to spend 1 hour to 2 hours a day learning concepts that will help me in my career, maybe building some projects, or just reading things that I found interesting. So how this works, I already told you about how this works. I know that the last couple of episodes weren't up to a standard that I wanted them to be. So I hope that this one will. I have everything prepared. Everything is ready. I will just do a quick mic check. Everything works. So without further ado, let's start. And start we will, because what I want to do here is the following. Let me also open my tablet as well. So this will be what we will do now is actually that we will try to implement a real-life application of predictions. Basically, we have a data set here. Do you want to install the recommended Rainbow CSV extension? No, I don't want to. So this is our data set. This data set has how many rows? 2,519. Actually, I won't be gathering data from the dataset itself because I already have my file, my scripting file, where I will do some analysis. First off, let's just walk through a couple of basic commands that I will do. What I did, is this working? It is working. So what I did, I made sure that I have pandas installed. Then I imported pandas and then I loaded my dataset. I used this because it's in CSV. If it was in Excel, I think I would use a different method. I don't know which one. Not important. Let me comment out this. So data frame.shape. It gives us the basic information about rows and columns. In this case, it says that we have 2,518 rows and 40 columns here. If I uncomment the second line, this will return a list of all column names. Price, area, location, number of bedrooms, resale, maintenance staff, all of this jazz. Data frame.head will give us a preview of the first couple of rows. And based on a visual analysis, like at a first glance, we can see that a lot of this data has already been cleared and standardized. We have zeros and ones. I already did something similar for housing. We had housing data, I think it was in California, and there was a lot of pre-processing there. We had to clean it, we had to standardize it, and stuff like that. Here we already have it. I mean, this is a more simpler example, so it makes sense. What else? Data frame info. So what is this one telling us? This one is giving us information about each column's type, how many non-null values there are, and the amount of total memory usage. Okay, nothing important. So dfdescribe gives us a more statistical data. We have numerical columns, and for numerical columns we have quartiles, we have the mean, the standard deviation, the minimum, stuff like that. I don't think that's important. What else? Bum. So data frame swimming pool dot unique, it checks unique values in the column. I'm gonna do the same. Data frame swimming pool dot value counts. If I run it now, oh, so it tells us, so it has zeros, ones, and nines. No idea what a 9 is, but we have zeros, 1, and 9s. Three different values we have here. Okay. So that's it about the most basic things. Let's now do something that might be more interesting. Okay, let me go back. Can I open this? Yeah. Oh, it's me. I'm live. Okay, so what we want to do, we want to train a linear regression model. And we will learn the command for that as well. So, okay. We want to train a linear regression model that predicts house prices from features like area and number of bedrooms. We will use a linear regression from scikit-learn linear model. So from scikit-learn linear model, import linear regression. I almost probably need to install all of this. From scikit-learn metrics, import mean squared error, import numpy as np. So just to refresh our memory, pandas is used to handle datasets. And you can see here, we actually are reading our dataset using pandas. I don't have these two yet, but basically linear regression is scikit's regression model, and mean squared error will be used to calculate RMSI, the error metric. If you remember, I talked about error metric before. I talked about it. I will just make sure. I'm sorry if that my mic is still on. Yeah, it is. It is my mic. My mic is still on. And then I have numpy. Numpy will be used to do some higher maths that I'm too stupid to understand. So I have a data set. With this, I read it, I created a data frame. I'm gonna comment all of these out. I don't want them to take any space. What? No module names Oh yeah, I need to install it. Let me Google it. Google, please tell me. No one uses Google anymore. Please tell me how to install sklearn in Python. It's most probably just pip install scikit-learn. I assume it's only this. Ah, it's done. Oh, quick. So if I run it again, load. 1 second to import all of these libraries. No, a bit too much. All right. So now we need to train a model. How can we train a model with multiple features? I'm gonna do X, and I'm gonna say data. What am I pulling? Area and number of bedrooms. If you are asking where am I pulling these informations, I'm pulling them from the columns. If I comment this line, you will see the list of columns that we are having. So, and I'm not going from data, I'm going from data frame, and I have Y, it's gonna be data frame, and it's gonna be price. Why? Because that's the target. And if I do model linear regression, model fit XY, all right, X is the feature matrix, Y is the target. By using .fit, we are training the linear regression model here. And now there's our linear regression object or class. Now what we need to do is to predict it. So after this, let's create a new house. The new house data frame. So the new house will have an area of 1000, but I did something wrong here. I did this wrong here. And the number of bedrooms will be 3. So what should I do here now? I'm gonna create a prediction. Prediction model predict house print prediction. So this would be the predicted price. And now if I go here and let me just see, the number of bedrooms is 3. I can also train a simpler model that has only 1 feature, or I can train a more complex one that have more features. We'll talk about this later on. I'll just do something else now. So here, if I do, so I printed the prediction. If I do now print model coefficient 0, so this will be the slope, and print model intercept. So this will be the bias. Interesting. So what is happening here? This means that our formula based on these parameters, actually we have two parameters, but basically based on these two parameters, and this is area, which means that each square meter adds about 10,000 units of whatever currency we are using to the predicted price. There's no way that the base model is for what? What else we want to see? We often want to check how well the model fits the training data. So if I do model predict x numpy square root mean squared error y prediction. Let's see what the error is. And if I print RMSI, so this will give us the root mean squared error. Which is the average prediction error size. And why? It's quite a big one. Shouldn't be this big. Wait, prediction. Hey, what's up? I'm just looking at a really simple example of a linear regression model, and I'm trying to understand what is happening here. They want me to change my profession at work in order to be like, I don't know, AI, ML engineer, no idea what it is. So as someone who has never worked with it, I'm just going through the basics. Why is the error this big, man? So what my code is doing, I have the feature matrix, I have the target here, then I created the linear regression model, I trained it with the coefficients and the intercept. And then I created a prediction for a 1000 area 3-bedroom house. So this is the slope only for area, and this is the intercept. And this should predict prices for all houses in the tree. I know what the issue is. So this is quite a big 4, 8. This is in millions, man. So yeah, this is in millions. Bye bye. Yeah, I think the reason why I have an error this big is because my model is only using area in bedrooms. Price may also depend on location, the year built, bathrooms, garage, conditions, all the other things. If it's using only area in the number of bedrooms, yeah, of course it's gonna be a bit faulty. So I need to add more relevant features if available. Also, another issue might be, and these are just going from top of my head, that, for example, feature and price, the features that we selected and price has a straight line relationship, which in reality price often grows non-linearly. Okay, so all of these are some things that we will fix in the future. But first, let's talk about something else. No. So what I wanted to go through now is that we just learned how to find the best line for the data if the data has the shape of a line. But what happens if the data doesn't resemble a line? So there's another section called polynomial regression, that handles cases where data is a bit more complex. So first of all, what are polynomials? Are you teaching maths? Hey, no, I'm teaching my son. So if you came here to learn something from me, I don't know. I don't know if you will learn anything. I'm teaching myself and not maths. I'm teaching machine learning because the company I'm working for is planning to promote me, quote unquote, promote me, so I can work. Polynomials are algebraic expression whose power of variables are whole numbers. I didn't know that, man. Thank you for telling it. This is all like new for me. Okay, so what's a polynomial? A polynomial is a mathematical expression made by adding terms that involve constants, variables, and exponents. And these are combined using addition, subtraction, or multiplication. Okay. Polynomial. Polynomials. I hate when I'm reading a book. Yeah, thanks. I mean, I remember all of this from high school and university, but since I started working like as a software engineer, I didn't use a lot of math, to be honest, and I forgot most of it. I just hate the fact because I'm having Yeah. This is basically what's written in the book I'm following. You know what I'm hating? Like the fact that the books are so dense. Instead of explaining things simpler, for example, it says here this is the general form of a polynomial. So I have an xn, right? Plus an minus 1 x to the n minus 1 plus, all right, 3 dots. We have the 3 dots. A1 to x plus A0. I know this is the general form, but maybe they should have just given me something really simple for idiots, for dummies, because I'm a dummy. So what do we have here? So here it says these are coefficients, right? And n is the degree of the polynomial, which is the highest power of x, whatever this means. Okay, and also I have x, and x is my variable. And I know that when I did the linear regression, like the linear equation is also a polynomial because it's, for example, 2x plus 3. It follows this shape here of the polynomial. This is in the end just a line, right? I have what? No, sorry. I have 2, and 2 is a slope, and I have 3. 3 is the intercept. N means the degree. So yeah. So if, for example, like I have 2x third plus 3x squared plus x plus 1. I assume this is the degree here. Okay, so this is the linear degree. All right. Linear. Wait. Linear. Where's my mouse? Linear equation graph. All right, so this is the linear. No, wait. The linear equation. So it's only a line, which makes sense. But if I do now, can I reduce this? Yes, I do. But if I do now, where's my book here? Ah, it's here. Px, for example, x squared plus 2x plus 1. So this is a quadratic degree, right? Quadratic degree. Yeah. And this says the shape of a parabola. I have a problem. When I'm learning these things, I'm always asking myself why, instead of just, learning some other basic things and then saying, okay, now I can go back and I can learn. Yeah, it is from GTA. Wait, bam. Yeah, it's that country state. I remember I used to play that. What's the name? That Kairos radio station, and driving my pickup truck there. I like to collect cool wallpapers. I hope you also like my wallpaper for my tablet as well. Okay. Last month, you're never late, man. It's I remember. I mean, San Andreas was a huge part of my childhood. But I remember when I played older games than San Andreas, like I don't know, the games when I was a kid, or I get a really good feeling of nostalgia. So I understand how cool it is to play, to play old games, and they were made with more love, definitely. All right, so and also I have the cubic equation. Cubic equation. This is shaped like an S shape. Now, the question I need to ask myself. Why is the linear equation a line? The quadratic, a parabola, and so on. All right, I'm gonna ask this ChatGPT. I was born after GTA 4. What? I mean, okay, you are like what? Even if you are born after GTA 4, GTA 4 came in. Wait, 2004, I think, right? GTA 4 release, yeah, 2000. No, 2008. 2008. Man, you can legally drink. So, can you? 2025 minus 2008. No, I don't want to see the casual. I want to see 17. I mean, you can almost legally drink. Oops. Oops. You must be kidding me. This will only take a few seconds. Confirm you're a human being. This was a simple human being test ever. All right. Okay. Let me go back to polynomials. So polynomials describe relationship between variables. I don't drink also. Minimum age is 20. Ah, you from the US. America. America. Yeah, I mean alcohol is really overrated. I used to drink a lot when I was I don't know, 18 to 22, maybe 17 to 22 with my friends. Ah, from India. Wait, you also have like the limit of 21 years of age. Polynomials describe relation. I didn't know this. I didn't know this, man. But the alcohol is so overrated, man. I mean, it's good if you have good friends with whom you can feel like, I don't know, a good connection while drinking, but usually it just feels bad. All right, so yeah, let's go back to the polynomials, brother. Polynomials describe relationships between variables. They're used when relationships are. Let me ask you: are you studying like to be in IT in the future? They're used when relationships are not perfectly linear, but still smooth and continuous. No, no, man, I'm not teaching my company. My company is giving me an option to promote. Uh, but for that, I would need to learn myself. I'm not teaching anyone else. I'm learning. I'm teaching myself, man. I don't know anything. I'm a software engineer, and they actually had two possibilities. One of them is to do some machine learning, and the second one is to do some reverse engineering. And I think I'm gonna try both because software engineering gets tedious after 5 years of working on it. Yeah, I mean, IT, even now with AI, I think IT is still pretty sought after. I think you'll find something good, man. You'll definitely find something good. Man, web dev and software engineering is always in high demand. It was, oh, 5 years, 10 years ago, it was amazingly in demand. Nowadays, maybe a little bit less, but it's still, even like there's no way AI is gonna replace you. I've been working, I've been in my old company, I was rewriting an app and I used AI. They told me to use an AI. And oh, it, it, it wasn't good. You still need to mentor the agent, you still need to give him guidelines, you still need to say, okay, this isn't good, you need to do this better and stuff like that. So, yeah. Your channel is. Someone already told me that, man. That Duke means sadness in Hindi. The Duke is actually just a portion of my surname, like the first part of it. Yeah, I remember one time, I think a girl told me like it means sadness. I had a couple of Indian colleagues. They were good engineers, decent engineers. Okay, man. I need to focus. I'm sorry. I'm sorry. I I really enjoyed meeting you. I need to get this grind going. Okay, polynomials describe relationships between variables. They're used when relationships are not perfectly linear but still smooth and continuous. All right, so we have something like this. A linear model could say something like this. I have a price, and the price is 500 times area plus 20k. So what is this meaning? What is this meaning? Which means, okay, a bigger house, there's a higher price in a straight line. But in reality, price may be growing slower for very large houses. So we can have another polynomial. Price is 2 times area squared plus 500 times area plus 20,000. So a linear model might say that we have a bigger house, a higher price in a straight line. But for really big houses, like here, the price grows slower, right? Right, makes sense. So this polynomial, this right here, which is the quadratic polynomial, allows and fits better in reality than a straight line. So why are polynomials important? Because with polynomials we do linear regressions, all right? Because with standard linear regression we can draw standard lines. But if we add polynomial terms like x squared, x cubed, and so on, we can fit curves. And if we fit curves, we can predict prices, we can predict stock trends, we can predict Friedrichs experiments. Okay. How long have I been doing this, brother? Okay. Okay, so this is a polynomial. I also worked with polynomials because every line is a polynomial of degree 1. And then we have parabolas, which are example of polynomials of degree 2. And a polynomial is a function in one variable that can be expressed as a sum of multiple powers of this variable. Okay. And the degree of the polynomial is the exponent of the highest power in the expression of the polynomial. So in this case here, has the degree 2 because 2 is the highest exponent that the variable x is raised to. Okay. Ah, okay, so this makes sense. Now, this is something that I didn't know. This is something that I didn't know, and it makes a lot of sense. So let me just draw this a bit better. So basically, the polynomial has what kind? Zigzag. Yeah, I wanted this is actually what I just read, and it made sense. Basically, so it seems that number of time the graph is oscillating is related to the degree of the polynomial. So, for example, if y is equal to 4, 1, 2, 3, 4. Let's say this is 4. Wait, let me use a different color for this. So if y is equal to 4 and this is 4, this is the 0 degree. But for example, if y is, and it makes a lot of sense, man, 3x plus 4. So it's going through 4, but it's 3x plus 4, so it will be something like this. It's a line. But if I have, for example, x squared minus 2x minus 3, it would look like this. And then if I have something like x cubed plus 2x squared minus 4x minus 1, it will have 2 zigzags. Yeah. So for example, if we add multiple here, multiple degrees, it will have these many amounts of zigzags. Okay, so polynomials of degree 0 are flat lines. Polynomials of degree 1 are lines with slopes that are different from 0. Polynomials of degree 2 are quadratics or parabolas, and this is polynomial of degree 2. It looks like a curve, as you said, a zigzag curve, and it oscillates twice. But also they can potentially oscillate fewer times. Okay, so if you had a degree, a polynomial of degree 100, I know that it would oscillate at most 99 times. Why is there a Peugeot in my background here? I was talking about I was calculating your age. Polynomials zigzag. I don't know why I Google polynomial zigzag. It doesn't make any sense. Zigzag. Okay, it doesn't make. Let me turn this off. Okay, so what happens? What happens if I have something like this? If I had nonlinear data? In my last live streams, I was working with linear data, but what if I have here the following? If I have this and 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 this, I'm just free shotting it. I'm randomizing it. So this seems nonlinear. I can't just, you know, pull a straight line here and says, oh, it's modeling this data perfectly. These are the points on a graph for now. So what I want to do, and what I did, and what I'm learning now for machine learning is basically how to predict the line. Wait, let me see if I have something here that I did already. Here. So I have these dots here, the yellow ones. So I want to predict a line that goes through these dots as closely as possible. And with dots that are in a more linear shape, like these dots here, like these yellow dots here, we can simply calculate a line. We can use linear regression to calculate and model this line. And for example, we can also predict this red dot here that we didn't have before for the number 4. I can predict the value on the y-axis of this red dot. And it's simple, so we have just a straight line. They're randomized on purpose, because in order to draw them, so you cannot do that. We cannot, yeah, you're right, we cannot draw a straight line, but we can do something else. We can use the quadratic equation and fit these dots, or I don't know, maybe some other equation fits better, something like this, I don't know. But we can use polynomials in order to fit these points. These are just randomized points, scattered. I drew them from my head. They're not real in a sense. Okay. No. We are going a step further. Hopefully I don't succumb the pressure. Sometimes I'm just scared, you know. I remember when I started working, I was thinking, okay, maybe I will be too stupid to do something. And sometimes you are. I mean, you're not too stupid, but there are people who are, I don't know if they are just smarter or they understand things better. Yeah, parabolas will work. The only difference is that we need to add more columns. Okay, so what do we have else here? Okay, what else? So we can do this. I don't need to run a straight line. I can't run a straight line here. Okay, let me just move this a bit down. Let me take another color. But how do I do this? I need to add more columns to our datasets. Okay, so if my dataset has only one feature, if it has the x of area, right? This will produce a linear equation. But if I have x of area and areas, not cubed, area squared, this will produce a quadratic model, right? If I have x is area area squared, area cubed. This will produce a cubic model. So our prediction will look something like this. Y hat is weight 1x plus weight 2x squared plus weight 2x cubed plus the intercept. And in real life, okay, in real life, if I had something like this, if I had an area and the price, so if the area is 1000 square, whatever, square meter squared, 1500, 2000 and 2500. And if the first one is 250k, the second one is 350k, the third one is 60k, and the fourth one is what? And the fourth one is a million. So, and if I try to model this, clearly this is not aligned because prices are growing faster with large houses, right? So I need to remodel my line. I need to think of a new model, and I need to use area squared or area cubed as features. And now we can draw a curve that bends to fit the data. Yes, so a degree 1 is the line. It may underfit. Degree 2 or 3 is gonna give a smooth curve. It's a good choice. Degree 50 may overfit. So we can either underfit, fit, or overfit. So let's talk something else. Let's talk. What do I have? Am I zoomed enough? It's 160 the optimum. I have params versus hyperparams. So what are these what are these things? How else? Ah, right. What are params and what are hyperparams? Okay, params are the numbers the model learns during training. Okay. Hey, thank you so much for joining. Even though, man, don't worry, I don't understand most of it either. I mean, this is really like domain-specific machine learning. Even though this is relatively simple. See you next time. Thank you so much. See you. Bye bye. Okay, so params are the numbers the model learns during training. Learns during training. For example, weights, and intercepts, like B. So parameters are starting randomly, and then we are using gradient descent or another solver to update them until the model fits the data. Okay, so these are the parameters. And hyperparameters are the settings we choose before training. All right. Settings we choose before training. Like, what do I have? The learning rate. What do I have? The number of epochs, degree of polynomials, blah blah blah. So the difference between params and hyperparams, that one of them are learned as we go through our model, and the second one are being configured, they're being set. So basically, if the model updates it, it's a param. But if the model, if it is configured, it's a hyperparam. Okay, so where can we use regression? Oh, and machine learning. For example, we can generate good recommendations in YouTube, like algorithms generating you recommend videos on Netflix, on Facebook, on Spotify when it comes to music, on Amazon, maybe the products you want to buy. We create recommender systems, and the regression algorithm plays a huge role in most of these recommender systems. Price recommendation, like when we want to buy a house, we list like here. We list and we create a lot of data. So if the next time we are interested in a house or an apartment, we plug it in with the rest of the data, and we say, oh, okay, is this house underpriced or overpriced? Which is really interesting. Now, there are some exercises. I will do those exercises with you. I just need to get some water. I will be. Let me do this. Water break 5 minutes. All right, boys and girls, I'm back. The stream's still going. It's still going strong. I just got some water, and there's one extra thing I need to do before I continue the stream. Apologies. I need to ping my friend. I need to ping a friend of mine to confirm our gym appointment. Okay. Okay. Now, let's continue. I have 1 hour left. All right. I have 1 hour. My friend just messaged me to say he will send me a message. He will notify me when he leaves. So let's do an example. Let's do an example. Let's do an example. Let's do an example. So here it says. Here it says. Our website. Let's move this a bit down. And let me pick another color. And here it says, our website has trained a linear regression model to predict the amount of minutes that a user will spend on the site. The formula they have obtained is the following. So this is the formula. Formula for predicting the amount of minutes that the user will spend on this site. They're predicting how much time will the user stay on the site. So this is the formula. What's T? T is the amount of predicted time in minutes. And these are the features that we have here. D, M, Y, and A. And the features are called indicator variables. Let's say, okay, D is a variable that indicates if the user is on desktop. M is a variable that indicates if the user is on a mobile device. Y is a variable that indicates if the user is young, under 21 years old. And A is a variable that indicates if the user is an adult, 21 years or older. So, an example, if a user is 30 years old and on a desktop, then we will have T will be 1, M will be 0, Y would be 0, and this will be 1. Okay. Now the question is, if a 45-year-old, if a 45-year-old uses their phone, what is the expected time? What is the time they will spend on the site? Okay, so we have this formula. each coefficient is the extra minutes added when that indicator is 1. So we need to set the indicator, oops. So we need to set the indicators from the scenario. And the scenario is a 45-year-old user looks at the website from their phone. So in that case, it's an adult. So I'm gonna put A, it's gonna be 1. It's not young, so Y, it's gonna be 0. They use the phone. So M is gonna be 1. They're not using the desktop, so it's gonna be D by default. And if we plug this into the formula, so it's going to be 0 plus 0 times 5 multiplied by 1 plus 0 times 5, 0.5 multiplied by 0 plus 0.2 multiplied by 1 plus 1.5. And the value would be 2.2. So the expected time on the site is 2.2 minutes for the user. Okay. The intercept is our baseline, and each one adds its coefficient. Being on mobile, yeah, so being on mobile adds 0.5 minutes, and being on desktop adds 0.8. Basically, the highest coefficient I would have if the user is using the desktop and if they are a younger person. All right, so this was a pretty simple example. Let's do another one. Let's do another one. So this is the first example. And this will be the second one. So the second one says, let's say we have a medical data set. The medical data set predicts the expected lifespan of a patient. Predicts the So it predicts the expected lifespan weight of the patient. Just a second. Okay, so let's predict the lifespan of the patient. And we will have a lot of features in the dataset, and the model would assign a weight to these features. So what we need to see is we have some features for the following features. For the following features, we need to state if the weight, oh shit, my text is going upwards. We need to say whether we believe the weight is a positive number, a negative number, or 0. So remember, lifespan of the patient. The first predictor, the first feature is number of hours of exercise. What does this mean? If the patient trains more, it means that he or she is generally in a better health, which means that they will have a longer lifespan. So if we are predicting the lifespan of a patient, this means by default that we are looking at a positive correlation here, which means extra hour of exercise is adding to the lifespan. Okay, the second one is number of cigarettes smoked. Every cigarette smoked increases the health risk. It means we get a shorter lifespan. The weight sign is negative. Number of family members with health issues. More family members having health issues means that there is higher genetic risk for the patient to have health issues, which means that there's a lower life expectancy. So I'm gonna get a negative. Okay, what's the next? Number of siblings. The number of siblings that the patient has, usually it doesn't really affect the lifespan directly. Maybe indirectly in a tiny way, like if you have more siblings, you might get better social support. If you have more siblings, you might be stressed more, but they are mostly minuscule, unimportant. Number of times patient was hospitalized. Again, negative, because if you're hospitalized, it usually indicates a health issue. Now, the question also says here, the model has a bias. Do you think that the bias is positive or negative? So the bias is the baseline lifespan prediction when all features are 0. So if we have 0 exercise, if we smoked 0 cigarettes, if we don't have any family members with heart disease, if we don't have any siblings, and there are no times the patient has been hospitalized, of course the patient will have some lifespan, just from being human. So the bias must be positive on default. Okay, let's do the next example. Wait, am I still live? I am. How long am I streaming? 1 hour and 15 minutes. Oh, nice. Um, let's finish these exercises. I mean, these exercises are really dumb. They are stupid. But you gotta start somewhere. You gotta start somewhere, right? Okay, so let's do the third exercise. I'm gonna just fly through them because it's really simple. So let's say we have houses, and how am I gonna draw this? Like this, and like this, and do another line here, and maybe another line here. Okay. So I have houses. I'm gonna say house 1, house 2, house 3, house 4, and house 5. And then I have the size is 100, 200, 200 for this one, 250, 3, 2, 5. And the price is 200, 475, 400, 520, and 735. Let me just do this and move this to the center. Wait. Yeah, I just remembered I can do this at the end of my stream. So this is a data set of houses, and we have sizes and we have prices. And we trained a model where the prediction of the price of the house based on the size is the following. So this is the predicted price. It's 2s plus 50. So this is the size and this is the price. So now I mean, this is so stupid. This is really stupid. I don't know why I'm even doing these examples. Okay, so what we need to do here is the following. I need to calculate the predictions this model makes on the data set. I need to calculate the mean. What is this? What is this? I don't know why that happened. So let's continue. There's no notes. It's here. So what do I need to do here? Calculate the predictions that this model makes on the dataset. So this is the dataset, and now let's compute the predictions. For each house, I don't know, I don't want to do this. House 1. So the prediction would be 2 times 100 plus 50, and it would be 250. I'm not gonna write for this, so stupid. House 2 will be 450. House 3 would be 450 as well. House 4 would be 550. And house 5 would be 770. Apologies, my gym buddy is calling me. So I have predictions for these 5 houses, and now I want to calculate the errors and then the mean square error for this model. So this might be a bit more interesting. So house number 1, I'm going to just continue. So house number 1, the actual price is 200. The predicted price is 250, which means that the error is y minus y prim, or the price minus pi prim, sorry. But either way, let's say this is the same thing. And of course, we're gonna create an absolute value out of it. So 200 minus 250 is 50, and if I square it, it's gonna be 2500. This one is 25. If I square it, it's gonna be 625. This one is again 50, and it's gonna be 2500. This one is 30, it's gonna be 900, and this one is 35, and it's gonna be 1225. Now these guys here, now this is the error, and these guys here are the squared errors. Now let's calculate the root mean squared error. And the root mean squared error is the square root of the sum of all the errors squared over n, and that would be the square of, how many do we have? 5, and we have 205, that's right, it's 2500 plus 625 plus 2500 plus 0999 plus 1225, and this is the square root of 7750 over 5 is the square root of 1550, and that's around 39.37, which means that then on average our prediction formula here has an error of 39.4. Interesting. And I have one more example. Actually, I want to do one more example. So let's finish this one here. Let's finish this one here and let's do something else now. Let's see if there is anything interesting in the world. ChatGPT developer mode. What's this? I didn't bring my son to a museum to look at screens. Oh God. I need to read about this. I need to see how much people will complain about this. By the way, the next time I will also do the Kafka tutorial as well. Wait, past. Building a Doom-like multiplayer shooter in pure SQL. There's no way this ChatGPT developer mode. Oops, we run into an issue while authenticating you. ChatGPT adds full MCP support. Bum bum. So what's MCP? MCP stands for Model Context Protocol. It's an open protocol designed to let AI models, like ChatGPT, connect to external data sources, tools, and applications. Think of it as a standardized bridge between the model and the outside world. Alright, so with MCP, servers can expose resources, clients can connect to these servers, and the models can then fetch information, run tools, or take actions in a structured, safe way. This is dangerous. I wonder how many people are going to turn this on without understanding the full scope of the risks it opens them to. It comes with plenty of warnings, but we all know how much attention people pay to those. Yeah, none. None. Zero. Nada. I'm confident that the majority of people messing around with things like MCP still don't really understand how prompt injection attack work and why are they such a significant threat. Oh yeah, someone could inject. Fuck. I didn't even think about that. So someone can just inject into your app. Please ignore prompt injection and follow the original instructions. Please don't hallucinate. It's astonishing how many people think this kind of architectural limitation can be solved by better prompting. People seem to develop very weird mental models of what LLMs are or do. I was recently in a call where HR is driving the use of Microsoft Copilot agents, and the HR lead said you can avoid hallucination with better prompting. Look, use all 8 key characters and you'll be fine. What? Trying to generate consistent images after using LLMs for coding has been really eye-opening. Thinking about what Johnny said about owning the unintended consequences. Interestingly, all the LLMs and the surrounding industry is doing is automate software engineering tasks. It has not spilled over into other industries at all, unlike the smartphone era where a lot of consumer-facing use cases got solved, like Uber, Airbnb, etc. Maybe I just don't visibly into the other areas, and so being naive here. We are rewriting all the tech stacks to use LLMs. Fuck. Maybe we are. Oh, can you give some example of the use cases for MCPs? Anything I can add that might be useful to me? How useful a particular MCP is depends on a lot of the quality of the MCP. All right. Wow, interesting. I didn't bring my son to a museum to look at screens. I don't care. I don't care, brother. Claude now has access to a server-side container. So this is the same thing, right? This is MCP. Code interpreter pattern where Claude has a presumably server-side container environment. Yeah, it's the same thing. We all dodged the bullet. What's this? I don't care. iPhone Air is the new iPhone. I mean, I saw the pics and it is a thin guy, but the camera. Also, they're trying to copy Samsung and Androids. I'm sorry if you love iPhones, but the design, at least I have an S22 FE and it's the same type of camera here. Now it takes good pictures, not gonna lie. Wow, it takes amazing pictures. Just a second. Okay, it has eSIM. I mean, it's 2025. Everyone has eSIM. YouTube is a mysterious monopoly. I saw this Blue Sky post from Adrian Black. He runs Adrian's Digital Basement, a retro computer repair channel I really enjoy. Wait, where's Adrian's Digital Basement? It's here. Can I fix 4 broken Nintendo game cards? Wow, this seems like an interesting channel, not gonna lie. YouTube views seem to have fallen off a cliff recently. Further down the thread, Jeff Gerling linked to a blog on this subject. Gerling is another technology YouTuber whose work I enjoy. Jeff Gerling. Fuck, both of these channels seem really cool. I think I'm gonna keep them in my backlog. He's also seen a large drop in views. In that post, Gerling shares some data. While views are down, likes and revenue have been mostly steady. Wow. You know, I'm a small channel, and in the end, I'm not doing this for. Can I increase this a bit? For views. Let me just take another look here. 100k, 100k, 80k, 100k, 200k, 200k. Yeah. I think at one point there's just a cutoff, but while views are down, likes and revenue have been mostly steady. Girling also noted that many people on YouTube are paid by sponsors. And those sponsors use recent video views as a key metric. Oh, there's also a video on it.
So what's up?
You can say that.
YouTube will no longer demonetize videos with strong profanity in the first 7 seconds, but you still need to choose your fucks carefully.
In the first 5 seconds.
I pay for YouTube Premium. Wow, interesting. Building a Doom-like multiplayer shooter in pure SQL. Patrick's excellent Doom clone running in a browser powered by tchdy Wasm. I wanted to push his awesome idea to the logical extreme. Build a multiplayer Doom-like shooter entirely in SQL with tchdy. This is not real, man. State lives in tables. Rendering is a stack of SQL views that implements raycasting and sprite projection. The game loop is a tiny shell script that executes as an SQL file 30 times per second. The client is 150 lines of Python. It pulls for input and queries a database for a 3D view. I'm gonna keep this in the backlog because I think I need to go soon. I'm having my gym appointment. No, I have 30 minutes. Internet ads are horrible. They waste your time, and the advertisement industry makes the internet a worse place. Payouts are so small that the only way to survive is to turn your site into an ad-filled hellhole with no real substance. If you want to support your favorite authors, send them money. Yeah, I agree with this one. Wholeheartedly, I agree with this one. $1 helps more than viewing ads ever would. However, most people see advertising as a part of the internet experience, which is why I added this message to my site. No ad blocker detected. Consider using an extension like uBlock Origin to save time and bandwidth. Ah! Spotting AI articles, yeah. It's shown off to the side and never covers content. It won't be shown if there isn't enough space. The close button actually works and stays closed. Okay, not in this case. The specific recommendation is important because a lot of people have only heard of ad blockers from ads. Ah, yeah. I was confused for a moment. I thought, what do you mean they only heard about ad blockers from ads? It's because you get a notification, oh, this is detected. But if you never heard of ad blockers, how how do the pages say we have detected an ad block? Commercial ad blockers range from sketchy to outright scams. If they are paying to be promoted, they must expect to make money from users. Imagine creating an ad blocker and then you expect to be promoted. The page itself contains a div to hold the message and tries to load a script called native ads.js. Okay, so we have a script. And here there's a div. It has an ID. There's a class. There are multiple classes. And the script adds the actual message into the document. So you get the add node, which is it's supposed to be this one, right? Document a get element by ID, add node dot ID is add node hidden. So we are using this to hide them. All right. Otherwise, I'm going with the add node content wrapper, which is this bad boy right here. And I set inner HTML to nothing. There's the cookie, which I set to this. If there's no cookie saying that has the notice shown, I'm switching this to be add node. No ad blocker detected. Click here to close. There's a bit of CSS. This message won't be visible if an ad blocker removes the div element. Okay. I mean, this is funny. This is more like a trick. I was thinking, where's the author going with this? Basically, they have like a pop-up here, and there are all of these classes that are most probably classes. Yeah, classes that are related to ad-like class names. This message won't be shown in browser that don't support JavaScript because those don't need ad blockers to begin with. It should be functional without CSS, but I can't think of any browser that support JS but not CSS. This is really cool. Because I'm not running an ad block, but I'm running Brave, so most probably I don't see this. It has been almost 200 years since the oldest surviving photograph has been taken. What? Let me bookmark this guy. I love this. How many posts does he have? I love these articles because they are general enough to be interesting to a lot of people. Short enough to be entertaining. And also there's a lot of details as well. Optimize cyanotypes. To be honest, I don't know what this is, so I'm gonna just close it. So let's see. How to spot AI articles. Fully LLM generated content is increasingly common on the internet. You know what I noticed as well? There are video essays ranging from half an hour to multiple hours that are completely, and when I say completely AI generated. The narration not the script is AI generated, and they have this guy or a girl, and mostly they are those Zuber types with those funny mustaches and those rotten ass tattoos, and they are reading this, and it's obvious to me. It's fucking obvious that they haven't written that. They just pumped ChatGPT or Mistral or Gemini with information about, oh, please generate me an article about why are you procrastinating and you are not motivated and focused enough to do your job, but maybe give it Studio Ghibli vibe or something like this. And they'll read it to you later, and it's obviously not theirs, and it's obviously fake, man. It's not just random people copying for ChatGPT. There are even companies offering fully automated AI contact as a service. Just send them a list of URLs to copy, and they'll send you an article-shaped object. To get a look at what the output looks like, I ran one of these tools on a recent blog post of mine. Let's take a photo. Maurici's blog explores the tactile, chemical, and optical pleasures of traditional photography alongside practical tactile. This is a word that ChatGPT uses often. Tactile. This post focuses on silver-based photographic methods, iron and cyanotypes alternatives, and the craft of contact printing, finishing with a look at camera choices and user techniques that help transform an idea into a tangible print. This is also a common AI generated text. Whether the reader is a newcomer curious about the historical processes of a seasoned printer seeking a refresher, the aim is to present a clear, engaging explanations that encourage experimentation and thoughtful practice. I mean, it's too surgical. That's the issue. The tool reused my page title, which includes the name of my site. They are fully automated, churning out thousands of pages with no oversight. If you see a title like that anywhere except a blog by someone named Maurici, it's stolen. Interestingly, it manages to use almost 100 words to say nothing. The only real content here is the posts about silver and iron-based photography methods, contact printing, and cameras. The rest is filler and a pointless sales pitch. Yeah, that's what I meant. It's too surgical. It's too vague. And all of these words, are like, if someone uses tactile, it's fucking AI generated. I don't care. What even means tactile? Tangible, perceptible to the sense of touch. Can I see, like, maybe I can see it right now, but in like 5 years, maybe we can see how some words, how the use of some words has changed as the time went on. I swear, we would see which words AI prefers, LLMs prefer. The rest is filler and a pointless sales pitch, so it is also AI generated. Silver photography techniques. Silver photography rests on light sensitive silver. Hell, I don't know what this means. The text recovers a wide range of practices working with. So I don't know about, you know, the concept of silver photography, so I don't know how much I would understand this, but okay, this is an AI generated sentence. Darkroom practitioners often describe silver processes as a dialogue between intention and serendipity. What's serendipity, man? John Cusack and Kim Beckinsale. I just know it's a pathetic rom-com. The faculty of making fortunate discoveries by accident. All right. Moreover, paper selection, fiber-based versus racing coated, warm toned versus neutral plays a decisive role in how silver gelatin. Alright, so I assume the author will say that LLM has again said nothing of value. Both paragraphs are very general. They don't talk about any specific film or paper or how a particular photo was taken, but about photography in general. This isn't universal, but it's the default for most LLMs. Again, it's mostly filler, yeah. Like they took a one sentence overview and stretched it out, yeah. The second paragraph is entirely fluff. Overview of silver processes. There are two primary ways silver is used in traditional photography. They said this already, right? Somewhere above, all right. In silver gelatin, printing paper coated with the silver is quote. So, again, I'm not using this photography technique, so I don't know whether LLM has generated good content or not, but the text is generated. It's so surgical. It's so surgical. Let me just close the other tabs. Finally, something. Okay, it doesn't tell us what the chemicals are or how they work or how to use them, but it does give something to Google. Although it couldn't stop itself from throwing in some fluff at the end. Each chemical better. Yeah, oh fuck, this is also so AI generated. And an AI generated image. This isn't universal. Some plagiarism machines grab images from the original or elsewhere on the internet, but it's quite common. Apart from being fake, the image is just wrong. Photographic chemistry is almost always done in the dark and never in metal containers. That being said, factual errors are hard to spot unless you already know a lot about the topic. Yeah, I mean, if this was a somewhat different topic, I could maybe understand this better. What's not hard to notice is the weird placement. Considering that it's not showing anything in particular, it would make much more sense to have it at the top of the section instead of the middle, a place where I expect a technical diagram of photo of result. Alright, so okay. Film photography follows a similar chemistry, but inside a flexible film base. Sheet film, roll film, and various professional formats give different grade instructions and tonal behaviors, making each format suitable for specific visual goals. Another LLM fluff right there, ladies and gentlemen. Cross-processing and alternative developers offer create another LLM. So a third of the paragraph is just AI nonsense. Silver-based images are renowned for it. Again. This is me writing my elementary school papers. Properly put. This is another AI generated image. Look at camera's logo. Okay. The paragraph itself is flowery and just plain wrong. Okay. Beyond archival qualities, tactile pleasures, and a direct connection to craft. My fucking god. Darkroom practice encourages a slower, more mindful approach, mixing chemistry more fluff. Yeah, this whole paragraph is fluff. LLMs tend to spew praise. You'll hardly ever see. By the way, shout out to Maurici. Please, if you haven't, take a look at his blog. It's really interesting. M-A-U-R-I-C-I. urcycyz.com. Iron and cyanotype methods. Iron processes like cyanotype and other ferric-based techniques processes like cyanotype and other present an accessible low toxicity alternative to silver. Okay, so this makes some sense. I don't know if it makes sense in the context of the topic, but it makes some sense. As it's not a regular LLM fluff. Cyanotype employs a light-sensitive mixture to ferric ammonium citrate and potassium ferricyanide, which after exposure to UV light reduces. Okay, so again, this seems like there's some content here. Ah, there's fluff again. The simplicity of cyanotype chemistry makes it ideal for teaching, outdoor workshops, and creative applications. Fuck me. This is the single most specific paragraph of the. I could guess. I could have guessed this. And it goes on to more fluff and names two processes that are never mentioned again. Other iron-based methods include Van Dyke. Haha. Produce sepia, calotype. Oh, you must be fucking kidding me. Look at this. Look at this. There's another fluffy article, fluffy paragraph right here. For an article on photography, it doesn't have too many photos. Key benefits of cyanotype. Let's see if there's something interesting here. Again, the thing is, I'm a complete noob when it comes to photography. So for me, I would read this and I would think, oh, this sounds smart, but most probably to someone who is already knowledgeable and knows a lot about the domain and the topic, you know, someone could understand the intricacies that AI uses to generate this. I can also still see, for example, this versatility encourages cross-disciplinary projects where photography blends with textile arts, bookmaking, and printmaking. So this is LLM. This is LLM generated. Cyanotype also offers a forgiving learning curve. Slight variations in technique often yield fascinating serendipity. Why are you using these words, motherfucker? Almost all of this was said before, and while this section is longer, it adds no further details. It's a useless section that any human writer would delete outright. Yeah. Or would, unless they are trying to stuff in keywords for search engines, in which case it's still garbage, just human-generated garbage. So I assume all of this, again, fluff. Oh, so there's some information here. Materials needs for contact printing, camera use in photography, no specific. Yeah, this is what I meant. There's very little large-scale structure beyond a paragraph or two. That's the problem with LLMs. That's the problem with LLMs. It doesn't structure. If it tries to rewrite something, it does structure it good. They are lifted from the original article. Interesting. In short, look for text lacking any specific details. Yeah. Articles that are repetitive and rambling. Yeah. Fluff. Using those stupid words and admiration. Flowery. Yeah. Positive wording. Yeah. Fuck. Encyclopedic tone. AI generated relevant images. Ooh, guys, this was fun, but it's already 2 hours and I need to hit the gym. Thank you so much for watching. See you in the next one.